Alright. So find f plus g of x. So let's add f and g together. So really all we're doing here is adding like terms. Right? I'm not going to write it out. Let's just, actually, I guess I won't write it out. So we have 2x plus 5 plus x squared minus 9. Okay? So technically we're taking that function and adding this function, but because it's adding, we just distribute the plus sign. So then we have x squared, and then we have 2 x's, so plus 2x, and we have 5 plus a negative 9, which is minus 4. And that's it. You just add the two functions together. When you're subtracting, the main thing here is you want to make sure you subtract every term. So f is 2x plus 5, and we're taking f and subtracting g. We're subtracting everything in g, though. That's the key, is that you need to do minus x squared and minus negative 9. Right? You don't have to write this step out if you don't want to, but you have to remember to subtract x squared and subtract the negative 9. So for subtraction, I do suggest writing this out so that you don't forget. So we have negative x squared, and then we have 2x, and then this is 5 minus a negative 9, which is really 5 plus 9, so that's 14. So the subtraction, just make sure you subtract both terms. Multiply f times g. So we have 2x plus 5 times x squared minus 9. Okay, we have a binomial times a binomial, so we're going to FOIL this, first, outer, inner, last. So 2x times x squared is 2x cubed. Outer, we have 2x times negative 9 is negative 18x. Inner is 5x squared. And then last times last is negative 45. So let's just simplify this. 2x cubed. Let's put our x squared term next, so plus 5x squared minus 18x minus 45. So we didn't simplify anything, we just wrote our terms in descending order. And then f divided by g. So f is 2x plus 5 divided by x squared minus 9. But we have to restrict the domain here because our denominator can't be 0. So x squared minus 9 can't be 0, so what numbers could we plug in for x that would make this denominator 0? 3 and negative 3. Yep. Now if you're like, okay, well x squared minus 9 is a difference of two perfect squares. Or there's actually two different ways you can think of this. You can say x squared minus 9 cannot equal 0. Add the 9 to both sides. And then square root both sides. And that means x cannot be plus or minus 3. If you guys see that right away, you don't need to do that work. Okay? I feel like, 3 and negative 3 would make that 0. So, I was just picture a number line, right? It can't be negative 3, it can't be 3. So it can be everywhere in between there. So when we write that in interval notation, that's from negative infinity up to negative 3, parentheses, because it's not included. We union that with negative 3 all the way up to 3. And we union that with 3 to infinity. Again, we're just practicing interval notation because you're going to use it quite a bit next year if you take calculus. So this is good to see it ahead of time. B. All right, we're going to do the same thing. So f plus g is the square root of x squared minus 4 plus x squared over x squared plus 1. And we're just going to leave it like that. All right, we don't have to actually add those. Same thing for subtraction. F minus g of x. It's going to take the square root of x squared minus 4 minus x squared over x squared plus 1. We're just going to leave that one. And then multiply. So here, so we're going to multiply these two. So I'm going to do x squared times the square root of x squared minus 4. I just put the x squared in front of the radical because that's usually what we do. Divided by our denominator, x squared plus 1. So we took g of x times f. And then division. F divided by g. So f was square root of x squared minus 4 divided by x squared over x squared plus 1. When you're dividing by a fraction, that's the same thing as multiplying by the reciprocal. So if I multiply, so dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm going to multiply by the reciprocal, x squared plus 1 over x squared. And then I'm just going to write the x squared plus 1 in front of the radical. And we'll put that in parentheses. All over x squared. In your homework, you guys can just go, if you see it, you can just go straight to here. We're going to go up, divide by fraction, let's multiply by the reciprocal, and then just go straight to this step. Now, we have to talk about our domain of f divided by g, because now we have a denominator. Well, we know we can't plug in 0 for x, or that will give us a denominator of 0, so we know that x can't be 0. But then, we also have an even radical in the numerator, and we need that even radical to be positive, because we don't want to take the square root of negative numbers. So this square root of x squared minus 4 has to be greater than or equal to 0. Okay, that just meaning it has to be positive. So square both sides, add the 4, and then square root both sides, and when you take the square root, you need plus or minus. Now this isn't entirely true. Right? X has to be greater than or equal to plus or minus 2. Okay? Let's think about, so this just gives us our special numbers, we'll call them, 2 and negative 2. Okay, but we need to think about, negative 2 and 2, we need to think about the numbers on either side or in between and see if they would work. So let's plug in 3. 3 squared is 9, 9 minus 4 is 5, and the square root of 5 is going to be positive. So the numbers to this side of 2 work. Okay, what about if I plug in a number in between negative 2 and 2? For example, 0. 0 squared minus 4 gives us negative 4. Can we take the square root of negative 4? No. So in between negative 2 and 2, right, and they can't equal negative 2 and 2. Or wait, yes they can. Yeah, never mind, sorry. So that's closed. Right, because if you plug in 2, then that's a square root of 0, which is fine. If you plug in negative 2, that's a square root of 0, which is fine. Right, we just need it to be positive. So that, we can't include those numbers. And then negative 3 squared is 9, 9 minus 4 is 5, and the square root of 5, that's fine, right? That's going to be positive. So it's actually not that x is greater than or equal to plus or minus 2. We got our numbers, and then we need to think about, well, where in relation to positive 2 and negative 2, which numbers work, okay? So just pick a number from each interval, plug in, and see if it works, okay? So actually, for our x values have to be less than or equal to negative 2 and greater than or equal to 2. And then we also said that x cannot equal 0. So now let's write that in interval notation. So we're going to go from negative infinity up to negative 2, and negative 2 can be included, so that was okay. I'm going to union that with, well, we said it can't be 0, but it doesn't matter because we're not including any values in this piece anyways. Right, so now our next piece is just 2 included all the way up to positive infinity. Since that ended up falling there, we didn't really have to do anything with it. And that's just for our domain of f over g. All right, any questions on those? That's about as hard as it's going to get, something like that. That was a very involved question. Evaluate means plug in. Evaluate when f of x is x squared minus 1 and g of x is x minus 2. So what we can do here is we can do f of 3 plus g of 3. So we can plug in 3 for x into both functions. So when I plug in 3, we get 3 squared minus 1, so that's 8, plus, when I plug in 3 into g, that's 3 minus 2, which is 1, and 8 plus 1 is 9. All right, f times g of 3t squared. So we can do f of 3t squared times g of 3t squared. Now, I'm going to tell you this. If you wanted to, you could find f plus g first. So you could add these together. So we get x squared plus x minus 3. Then you could plug in 3 into that. 9 plus 3 is 12, minus 3 is 9. You're going to get the same thing. However, this typically just tends to be more work. Okay, but you can do it. Okay, this just, I think it's just a little less work. So you could do either way, just so you guys know. So let's plug in 3t squared, and then that's squared minus 1 times, I'll just put that in, you can separate them, and then g of 3t squared. So that's 3t squared minus 2. All right, so let's simplify this. Exponent rules. You have to raise every factor to the second power. That includes the 3. Don't miss the 3. So this is 3 squared, which is 9. T squared to the second power, you multiply the exponent, so that's t to the 4th minus 1 times 3t squared minus 2. And now we have a binomial times a binomial, so we're going to FOIL it. First times first. 27t to the 6th power. Outer, negative 18t to the 4th. Inner, negative 3t squared. And last times last, negative 1 times negative 2 is plus 2. And then we're done. No like terms. We put them in order. So we're good. So again, if you wanted to multiply f times g first and then plug in 3t squared, you could, but it ends up being more work usually. We're going to skip this question. I just don't think it's really that important. Yeah. All right, composition of functions. There's an example, but this is on the next page. So composition of two functions. So the composition of the function f with the function g is, and I'm actually going to show you a picture first because I like this a lot. I think it describes what we're doing really well. So if we have our function f of x, and we have g of x, so we have a tree and a house, f of g of x means that we're taking g of x, which is the house, and we're putting it in the tree. That's a tree house. Okay? So g of x goes into f. So the house goes into the tree. If you do g of f of x, that means you're taking f of x, which is the tree, and you're putting it into the house. So you're putting it into g. Okay, there's a couple other ones here. I like the cookie sandwich one. F of x and g of x. F of g of x, so g is going into f. So it becomes an ice cream sandwich. And then g of f of x, you're taking the cookies, you're taking the f of x, and you're putting it into g of x. So cookies into ice cream, and you get cookie dough. Okay. So f of g of x is how we read this. F of g of x. And these two notations, it's just two different notations. They mean the same thing. So f of g of x means that we are going to take x, plug it into g, if it's a numerical value, and then we'll take that number and plug it into f. So you work from the inside out, okay? G of x, so then you take that and plug it into f. So let's do that. F of g of x. Another way to write that is f of g of x. So that means we're going to take g of x and plug it into f of x. So you always work from the inside out. So g of x, we're going to take this and plug it into f of x. So that gives us the cubed root of x cubed plus 1 and then minus 1. Maybe I should write f of g of x. Right, let's simplify this. 1 minus 1 is 0. So you get the cubed root of x cubed, which just is x. Okay? Cubed root and cubed cancel, so we just get x. Now let's find g of f. So g of f of x means that we're taking f of x and plugging it into g. So we're going to take this and plug it in to g. So again, we're working inside to the outside. So we get the cubed root of x minus 1 cubed and then plus 1. From these cancel, right? The cubed root and the cubed. So we get x minus 1 plus 1. That's 0, so we just get x. We'll learn tomorrow, since these both equal x, that does mean something, and we'll learn that tomorrow. It means that they are inverses of each other. That's not always going to happen, though. They're not inverses, that won't happen. So let's do, C. F of g of 0. So now they're giving us a specific x value to plug in. Now, we already found f of g of x. We said that it's x. Right? We already did f of g of x. So f of g is x. So we just plug 0 in, and it's just x, so it's just 0. Okay? Now, if, let's say you didn't already find that, you would plug 0 into g first. So you would get 0 cubed plus 1 is 1. And then you would take the 1 and plug it into the f. So 1 minus 1 is 0, and the cubed root of 0 is 0. Okay, but again, we already found f of g of x, so you plug it in, and that means that this is 0. All right, let's do it again. So f of g of x means we're going to work from the inside out. So we're going to take g of x and plug it in to f. So that gives me 3 times f minus x plus 5. So that's 15 minus 3x plus 5. And combine your like terms. 15 plus 5 is 20. So we get 20 minus 3x. Or negative 3x plus 20. Doesn't matter. All right, now let's do g of f of x. So that means we're taking f of x and plugging it in to g of x. We're going to take 3x plus 5 and plug it in for x there. The key here is this minus sign. Okay? So it's 5 minus, in parentheses, 3x plus 5. Again, you need to make sure you distribute that minus sign. So that's minus 3x minus 5. Combine like terms, and we just get negative 3x. And then last, we're going to find f of g of 0. So what they're really asking us, they're just saying, oh, plug a 0 in for x. Right? So we already found that that was 20 minus 3x, so let's plug in 0 for x. That's 20 minus 0, which is just 20. Okay. If we didn't already find that, then you would plug 0 into g first, and you get 5. and then you take 5 and plug it into f of x. And you get 15 plus 5 is 20. So, you work from the inside out. Is this review? Is this, have you seen this before? Okay, most of it. All right, domains. So, the domain of f of g is the set of all x in the domain of g, such that g of x is in the domain of f. Let's just do an example, and that'll make more sense. For the functions f of x, g of x, find the domain of f. Well, same thing. We can't have 0 in the denominator, so we know that x squared minus 1 cannot equal 0. Right? Denominator can't be 0. We don't want to divide by 0. So that means x squared cannot equal 1. Square root both sides. That means x squared cannot equal plus or minus 1. So if you picture that on a number line, we have negative 1 and 1, and we just want everything else in between there. Right, so in an interval notation, we're going from negative infinity to negative 1, not included, because it can't equal negative 1. We union that with negative 1 to positive 1, because we still need everything in between those numbers. And then we union that with 1 up to positive infinity. Again, I just draw the number line to help me write interval notation. That's what I visualize in my head when I write it. It's just helpful. You don't ever have to write it out, though. Okay. All right, B, the domain of G. G is just a line, x plus 1. Do we have to restrict the domain at all? No, it's just all real numbers. There's no even radicals, and there's no denominator. So we don't have to restrict anything from the domain. It's all real numbers. And then C, the domain of f of G. So we're going to plug G into f. So we're going to take x plus 1 and plug it into f. So we get 3 over x plus 1 quantity squared minus 1. And we're going to have to do some FOILing here. Hopefully by now you guys can kind of do this without even writing it out. Right? First times first, x times x is x squared. 1x plus 1x is 2x. And then 1 times 1 is plus 1. And then don't forget we still have this minus 1 here. So we get 3 over x squared plus 2x, right, because those 1's equal 0. And then let's pull out a GCF in the denominator of x. So we're factoring the denominator. X times x plus 2. So now we have 2 separate factors, and neither factor can equal 0. Otherwise, the whole denominator would be 0. Right? So x can't be 0, and x plus 2 can't be 0, which means x cannot equal negative 2. So technically our domain is all real numbers except 0 and negative 2. But let's just practice interval notation. So we can't include negative 2 and we can't include 0, but we do want everything in between those numbers. Okay. So that's negative infinity all the way up to negative 2, parenthesis, because it can't be negative 2. Union that with negative 2 up to 0. Union that with 0 up to infinity. Questions? All right, so a lot of this domain review is, we're doing this again. All right, last 2 questions. These ones go pretty fast. So use the graphs of f and g to evaluate the functions. F minus g of 1. So this means we can do f of 1 minus g of 1. F of 1, remember that means the height of f at the x value 1. So you're going to look at the x value 1, and what is the height of our graph? 2. Yep, so that's 2. G of 1, so when x is 1, what is the height of our graph? Or the y value? It's 3. So 2 minus 3 is negative 1. And if you guys just want to look, right, you don't even have to write this out on your homework. You can just say, oh, f of 4 is a height of 4 times g of 4. Well, g of 4 has a height of 0. When x is 4, the height is 0. So 4 times 0 is 0. Composition of functions. We have to work from the inside out. So we have to do g of 1 first. So g of 1, when x is 1, the height of our function is 3. And then, since g of 1 is 3, we're going to plug that into f. So f of 3, when the x value is 3, our height is 2. Again, you work from the inside out. G of 1, then take that result and plug it into f. So here we do f of 3 first. So f of 3 is 2. And we take that result and plug it into g. And g of 2 is 2. All right, last part. Find two functions f and g such that f of g of x equals h of x. And h of x equals 2x plus 1 quantity squared. So they're saying, there's actually a lot of different correct answers for this. Okay? They want you to tell me what is f of x and what is g of x. Well, since we're starting with g of x is the stuff inside. But you get to pick what the stuff inside is. That's up to you. So when I first look at this, I'm like, oh, the stuff inside that I'm plugging in is 2x plus 1. And what am I plugging that into? Well, this would just be x squared. Right? So if I have x squared, and I'm plugging g of x into that, then I would get 2x plus 1 quantity squared, which is our h of x function. Right? Was there anything else that you guys saw and you're like, oh, well, actually, I could just plug this in? And that, I think, most of us would probably see that as the stuff inside. But you could also do something like this. You could say g of x is this part, just the 2x. And what would you have to plug that? That would then become your x. So then f of x would be x plus 1 quantity squared. Right? So then if you plug g of x into here, then we end up with that function. Or you can even go as simple as saying that g of x is x. What are you plugging it into? 2x plus 1 quantity squared. Right? You could even go that simple. But personally, I just look at the stuff inside and I make that g of x. And I think that works the best. Okay, but there's multiple correct answers for that. Your homework, I'm so sorry. My room is humid. I don't know if it's humid, but it's like the papers get wet. So any papers I have sitting here, they just like curl. The sides will curl up. So you guys might notice when you write on your homework with pencil that it might be a little bit. You'll see. It's really annoying. I emailed them this morning. I was like, is there anything you guys can do? Because all my papers are wet. Hopefully it's not too bad. Alright, I tried to keep the homework assignment short, so I want your feedback tomorrow. Let me know how the link felt. And I'll do the first problem with you guys, number 9. Or there's number 7. We'll do number 9 together.